In the chemistry, we're going to have another exciting class time here. We're looking at significant digits or significant figures or Sig Figs as I call them. This is a very important concept. We will be using this all year long. Okay, what are Sig Figs? Means to determine the precision or certainty of a measure. So how confident are we in a measure? That's what Sig Figs are. Okay, so rules. Number one, all non-zero digits are significant. So if I have the number 2, 3, 4, 5, the number 0.00345, for 2, 3, 4, 5, I have 4 Sig Figs because they're all significant. For 0.00345, I only have 3 because these two zeros are placeholder. They won't tell me how far this is from this 3 is from the decimal place. They are not telling me any certainty of the measure. All right, so next rule. Zeros are not significant except, first of all, if a zero is between a non-zero digit. So, give the example 1,000,3000 or 0.004005. Case of 1,000,3000, I have 5 Sig Figs because these 3 zeros between the 1 and the 3. In the case of 0.004005, I have 4 Sig Figs because the 4 and the 5 are significant, the zeros between. These two again are placeholder zeros. These 3 again are placeholder zeros. Just tell me how far that digit is from the decimal place. All right, zero can be significant. It's after decimal to show exactness. So let's say I get number 1.2 with 1, 2, 3, 4, 5, 6 zeros, or 0.000020. We're using the zeros to show exactness. In the first case, I have 7 significant figures. They're all significant because they're after a number and after a decimal showing exactness. In the second example, I only have 2 Sig Figs because these 4 are just placeholder zeros. This 0 is the only one showing exactness to the tenths, 100,000, 10,000, 100,000, 100,000, 100,000th place. All right, last set of rules. 0 can be significant if it's above a bar is above it. So given the number 345000 with a bar over it, 00000. In that case, I have 6 significant figures. This only applies though if a number is greater than 10. It does not apply to decimals. So I give you the example 0.004005. It only has 4 Sig Figs, and we can't use a bar. How would I make it if I wanted 6 Sig Figs? Well, then I would use the last rule, and I would add 2 zeros after it to show exactness. All right, last set of rules. All constants and equalities are infinitely significant. So I'm going to give you an equality like 1 foot is equal to 12 inches, or value c, which is the speed of light, 3 times 10 to the 8 meters a second. Those are infinitely significant, as many Sig Figs as we need. Lastly, multiplication rules, addition, subtraction. Rule for addition, subtraction. Last filled column to the right is the level of significance. So if I give you the example 45.892 plus 2.9, the answer comes out to be 48.792, but the last filled column is that 7, and the number to the right of that 7 is a 9, which is 5 or greater, so the answer is 48.8. That's my answer. All right, for multiplication division, the rule is the least number of significant digits in the problem is the most you can have in the answer. So let's get the answer 34.9 and 12.4. If I divide that through, I get 2.81454.51629. Okay, in my problem, in 34.9, I have 3 Sig Figs. In 12.4, I have 3 Sig Figs. So I can only have 3 Sig Figs because 3 and 3, the least number is 3. So the answer would be 2.81. That number to the right, that 4 here is not greater than 5. So therefore, it is done. And if I check here, all right, that is my answer. All right, and I think, yes, the next set I'm going to have is practice. We'll do this in class, copy these down, we'll practice these through. Don't do these ahead of time. I want you to do these after as we discuss them in class. All right, that's it. Any questions, let me know. Thank you. Take care. Be good. Bye.